front row just in case.
Just in case.
You look so
You might
nice
need
in a
an
suit.
interpreter instead of a microphone. That might be a
True.
better option. So I'm Jon Schoonover. I'm with the SIU. We've done quite a bit of research at SIU in terms of looking at agricultural BMPs. So we started out looking at riparian buffers over about 18 years ago, I guess, in 2000. And then we started to move that into looking at concentrated flow paths because we saw that riparian buffers weren't doing what they were designed to do in terms of overland flow or surface runoff. So then we moved into we did some urban research in between, looking at urban development and things like that. But then we got back into agriculture and started looking at cover crops. And now, so we've done infield stuff. Now we're looking at kind of edge of field stuff. And now we're kind of blending the two together. So we're just trying to develop that BMP toolbox for farmers to use when these nutrient standards come down the line. So how many of you have some sort of tile drainage on your property? A couple of you? A few of you? Good. So obviously different parts of the state are going to have more of it and different kinds of it. So if you look over on the right side, this is what is predicted to have tile drainage, and that area you see in red obviously is your flatter land, so they're talking about more pattern type tile, right? If you look down in the south part of the state where I live in the green, you're going to be looking at more of the WASCoB type stuff, so water and sediment control basins and tiles associated with that. We also have some problem area tiles. So some of the common applications are obviously the pattern tile, and I'll show you a picture of each one of these. Most of you know what they are. And then problem area tile. And then to the west, kind of over by St. Clair County, there's a lot of terracing going on that has a tile that will drain that. And then we have water and sediment control basins as well. So this is just an example of a pattern tile system going in. You have a main line running down the edge of the field or in a ditch, and then you got feeder lines feeding to that main tile. So these are obviously going to be spaced differently based on soil textures, the hydraulic conductivity of that soil, how fast does the water move. So you have some as narrow as 20 feet on a spacing and some up to 100 feet or so. And then problem area tile is exactly what it sounds. So if you got a duck hole out in the middle of your field or frog hole, whatever kind, you got a low depressional area, right? And when those things dry up, you see all those little soil potato chips laying on the ground. That's that surface crust that is going to be problematic for the germination of your crop and the growth of your crop throughout that season. So you want to kind of dry those up, get rid of those. You'll put a tile out into that area, drain it, get the water off the site. So terracing, this is the one I said was more common in the western part of the state, and this is where most of the water quality research in terms of tile has come from. There's not as much on WASCoBs, but this is where they'll put a terrace along the field, along the contour of the hill, and there's a tile line running, and you'll see a standpipe there that'll take it down the slope. So it gradually slows the water down so you don't have that big erosive power of water moving down the hill. And then WASCoBs, this is the one we're looking at most recently. There's a lot of these on the landscape. They like me to use the word ubiquitous across the landscape. They're all over the place, right? So there's a ton of these out there, but there's not a lot of research on them. They're designed for slowing down water, and they're designed for sediment. So there's some research on that, but there's not much in terms of water quality, looking at the water chemistry. So that's what we're going to look at with that. So what does all this stuff mean to y'all? So this may cause increased nutrient loss from the fields, loading in the streams and water bodies. It can impact your neighbors because you're getting rid of water, you're putting it somewhere else, you're drying a wetland maybe. Can potentially stress the crops if unregulated. So if you don't have a problem tile in, it can stress crops. And then installation can be an expense, so cost per acre. And then it can also drain wetlands of importance. So what are the current management options? The NRCS has a bunch of conservation practices, all these different numbers. So the first one up on the list is bioreactors. I haven't done any research with a bioreactor, but there's a lot of folks doing those across the state. And that's where the water comes into a pit that has some type of wood chip in it. And that's just a carbon source for the nitrifying bacteria or denitrifying bacteria to denitrify that nitrate as it comes in. And then we have drainage water management. And I think if you have tile, if you have pattern tile, you should at least have this on the end of your system so you can control or regulate the water that leaves the field. So inside this control structure, you have a series of stop logs, and you can pull those out to let the water freely flow, or you can put them in to hold water back onto your site, onto your field. So if it was a very stressful year in terms of drought, you could put those stop logs back in and maintain some of that water on your field. Saturated buffers is one I want to talk about today as well. And then water and sediment control basins. We'll talk about those in more detail. So the research we've done so far at SIU has focused on saturated buffers, and I'll go into detail for those of you that don't know or haven't seen one of them installed. And what we've done, I always like to tweak things, so we've tweaked the design. So we came up with a 2-stage buffer. We figured if one stage was good, 2 stages would be better, right? Makes sense. And then we came up with a third design, which is a pitchfork design. So there's actually 3 lateral tile lines running out. And then WASCoBs, we're looking at cover crops. And like I said, we're going to focus on the water quality. So looking at a saturated buffer, this is what one looks like from an aerial view. You got your main tile line coming in from the field. It hits a control structure. Within that control structure, you got 3 chambers. The water comes over the first chamber so you can measure the discharge, how much water is coming in. The middle chamber, there's 2 lateral lines that go parallel to the stream or ditch. And then you got some sort of vegetation that lateral tile line is actually saturating. So you can have nutrient uptake from the plants and denitrification because you created that anaerobic environment. And then the 2-stage design is similar to the single stage, but instead of 2 control structure or 1 control structure, we now have 2. So when it bypasses that 3rd chamber, it will go into that next control structure and then fills it up, and the 2nd chamber moves it laterally again. So here in this situation, we have a cover crop strip and then a grass strip. So we're saturating those 2 zones. So what the objectives of that study were was to compare a standard saturated buffer to the 2-stage saturated buffer, and then we also had a control site where it was just a grass strip. So like there was no lateral movement of water. Water would just move through. Then we wanted to estimate runoff volumes reaching those tile outlets. So after it went through the control or the 2 different stages, and then quantify the economic cost and benefits associated with those practices. So the first one, Massac County, down there on Mr. Burnett's property. So we're looking at, this is more Ohio River Valley flatland, so that's the reason it was a pattern tile system down there, and we were looking at this 2-stage system. So here's an aerial photograph of the field. Down in the bottom right corner was our standard saturated buffer, and then in the middle here we have the 2-stage, and then up there was a control. The field sizes range from about 30 acres up to 60, and these were on 40-foot spacings. The tile were installed at 40-foot spacings. So this is looking at the discharge. The one thing you're going to notice, the green line is the control structure, where there is no saturated buffer at all, so there's no lateral lines going out. The red is the standard one, and it maintained a pretty low outflow compared to the control structure, and then the 2-stage was kind of in between. And what we thought was happening, and still think is happening, on the 2-stage buffer you got the 4 lateral lines going out, and when the water table would come up, they would actually start contributing back or draining to these control structures. So the outflow actually went up a little bit compared to a single standard saturated buffer. So our next tweaking that design to put some backflow valves on it so water can only go out but can't come back. So if a water table did get up above it, it's going to hold it out into the field so you can still have that potential denitrification. So looking at nitrate loads, pretty much the same trend with the hydrology. You got your control structure on the green line, has higher nitrate than both the 2-stage and single stage. The single stage was pretty low the whole time because it didn't have much water flowing through it. it was doing a pretty good job of treating what came in. And then you can see most of it was early season when you were losing it, and that's coincides with nutrient applications. Same exact pattern you saw with DRP, dissolved reactive phosphorus. So the results to this study were the predominant form of nitrogen leaving those fields was in the nitrate form. One thing I didn't talk about is there were also these wells, groundwater wells, where we would monitor nutrient concentrations coming through on a transect towards from the field to the stream. And these well elevations showed increased nitrate, which meant we were pushing it out there. So the nitrate was increasing in those saturated zones. And then the control structures did stabilize the flows. So we saw reduced outflow, and again, like I said, there was more flow reduced in the single stage than there actually was in the two stage. So what we thought in terms of, it didn't really show what we thought, but the reason why is it was contributing more groundwater. So that led to a partnership between the Farm Bureau, the NRCS, because we wanted to design a new saturated buffer and with their specifications, so it could be something they might use in a conservation practice down the line. And we also working with the Land Improvement Contractors of America as well on this project. So this is going to be up in Moultrie County around Shelbyville Lake. And so what we're trying to do with this pitchfork design is the same thing, looking at water quality, but we're adding that backflow valve and more lines going out laterally. So here's what the design will look like. We're going to do a side-by-side comparison between the two standard saturated buffer on the left over here, and then we're going to have the three pitchfork design on the right. And this outer line is also going to have a check valve on it so we can shut it off if we want to, in terms of like the farmer wants to get out in the field. You can shut that valve off so it's not saturating further out into the field. So that's what the design will look like. We have the tile water coming in, the main. It's going to be a 3-chambered box again. You got your backflow valves right here, and then over here you're going to be able to shut off that main line. And the thought behind this is we're going to triple the amount of water we're pushing out, and you can treat through nutrient uptake and denitrification. But it's not going to allow it to flow back. So once it goes out, it stays there until something in terms of denitrification or infiltrates, percolates down into the groundwater. So we've been out there, we've shot elevations, we know where to put these things in terms of slopes and everything in the field. And then we took soil samples so we can look at saturated hydraulic conductivity to know how far we've got to space these lines apart from one another. And that's where we're at with that project so far. So the next thing we're going to talk about is the WASCoB project, and this is the one that's going to go up in Menard County, right? So every county I've worked in so far, I live in Marion County, work in Menard County, Massac County, Moultrie County, everything's got an M. Work in Madison and Meriwether, everywhere I go has got an M. So that's a prerequisite, I guess. So in terms of these WASCoBs, we're going to look at the WASCoBs and we're going to add cover crop to some of them, look at the impact of cover crops and WASCoBs on water quality. And then we're also going to look at these ephemeral drains that do not have a WASCoB on them. So we're going to look at just free-flowing water, look at the water chemistry coming off of the field in that situation. So there's Menard County. This is the NRCS plan, the map. So this is what's going in. I don't know what the status of that is exactly right now. I know they were supposed to start November 12th. Are they there?
Yeah, the tile's in.
The tile's in the ground? That's good. So the next couple pictures, we're going to actually focus on this WASCoB right here. So when I go to the next slide, that's where we're at. So that's what that drain looks like. So there's a little hilly topography up there. I thought it was all flat north of 64, but apparently there's some hills up there. And there's a few trees you can see in the background. So it's basically like if I just went 5 miles down the road from Carbondale, but instead I'm driving 4 hours up north to see the same thing. But so this field's going to be the one with multiple WASCoBs put in. And here's what it currently looks like. So if you look at this tree line, you can see kind of a berm right there, and that was an old WASCoB. And you can see the tile line exposed right here in the bottom. So that thing apparently breached, I don't know how many years ago, but it didn't handle the capacity of the water coming down. But you can see upslope, this is a couple 100 feet, is where that water was all coming from. So the WASCoBs should have been started further up in the field. This thing was like down at the bottom. It was almost like a pond dam, really, because they put it down at the base of the valley, and then it just had too much water coming into it and it couldn't handle it all. So the new design has them starting, you can see the pink flags up there, but they're going to start way further up into the watershed. So we planted cereal rye out there for the cover crops on 10/30/18 at a seeding rate of 78 pounds per acre. That was a little higher than typically plant, but we broadcast seeded it. So hopefully we've got something coming up out there. I need to get up there and check it out. So installation, I guess, began the next day after this. On the 12th, we were out there visiting the site. So a little bit different in terms of installation. They're using a chain-driven plow instead of a normal plow, but I guess that'll get the job done just the same. And so all that stuff's going in the field as we speak, and we're going to start sampling that next spring. Hopefully, we've put in a couple proposals to get some more funding, but regardless, we're going to do the work. We're going to go forward. We just may not be able to equip it with all the same equipment. So in the end, what we're trying to do with this research is, like I said, there's multiple different things we've looked at. We've looked at these saturated buffers, we've looked at WASCoBs, we've looked at cover crops, we've looked at riparian buffers. We're doing all this stuff. Like I said, we're building up that toolbox for farmers to kind of pick and choose these different tools that work on their farms. Because not everywhere is not going to be able to have a WASCoB installed. If you got flat ground, it doesn't even make sense, right? So we're looking at this from a multiple phase reduction. We start over here on the left. This is all the infield things you can do, and these are some of the percent reductions you can see in the literature for following the 4R nutrient management or adding cover crops to the field. So that's like the first phase. If you can do that, all farmers can do that, right? That's all infield stuff. And then the next phase, if you have kind of hilly topography or you have a waterway that is designed where you could put a WASCoB, you can see another 50% or 80% reduction in phosphorus and in sediment. And then we don't know what the nitrogen reduction is because nobody's done anything like that. There's been a little bit of nutrient data on terracing, looking at terraces. Somebody over in Missouri and Nebraska has done a little bit of research on nutrients with terraces, but nothing on WASCoBs. And then further down the pipe, if you want to go down the tile line a little further, you can look at these control structures like we were talking, drainage water management, saturated buffers, whatever you want to put down at the end of the tile. So we want to be able to come up with, like I said, this toolbox that people can pick and choose what works best on their farms. And if you get, a 50% reduction here, what went down here, you can expect another 50% reduction possibly, until we just keep reducing that loading down the stream. So I'd like to thank all these folks. Illinois Nutrient Research and Education Council has funded a lot of this research, and hopefully will continue to do so in the future. And then Illinois Farm Bureau, specifically Lauren Lurkin, she's hooked me up with all these different landowners. A couple of them are in the room. And then the Land Improvement Contractors of America, Ryan. And then Ruth Book from the USDA, she's looking at some of these designs with us on the saturated buffers. And then we got a couple of the landowners, at least in here. Rollo Burnett from down at Massac County, Brian from Menard County, and then Clint. They're all in here. Bring the whiskey? Yeah, good. All right, and then our field techs, grad students, and everybody that's done all the work out in the field. So I'd like to thank all those folks and remind everybody that was out there, the beautiful weather we were in. It's about like the wind we have here. So does anybody have any questions?
Have you ever did any testing on where you run the water?